arithmetic and geometric sequences.
Oh, what is that?
You should have done this in Math 3.
Oh my God.
I know
no.
I taught it when I did Math 3.
We didn't learn, we had cross.
Oh, I didn't learn. Well, I did learn. We had straws.
Oh, yeah, I did have class. I had class.
They can relate.
I had straws, so.
The straw on the cross.
Okay, so we're going to look at stuff that's similar to this. 1, 3, 5, 7, 9. What pattern's happening here? Plus 2. Guess what? This is an arithmetic sequence. Anytime you add the same number over and over and over again is an arithmetic sequence. Or something like this. 1, 3, 27.
Right?
Oh, God.
What's happening here?
Times 3.
I'm multiplying by 3 each time. That is a geometric sequence.
I'm smart.
Okay, these are the two we're going to deal with. Okay, both of these sequences are in terms of population. So we're going to create mathematical models that demonstrate positive increase, so the population's growing, or a negative decay growth in a population. The species is dying off. Okay. So populations, these refer to humans. Okay, it can be any type of animal. It could be a plant. It could be bacteria.
Human.
Okay, it could basically be anything. You do deal with geometric sequences in biology and the growth of bacteria. Those are geometric sequences. We have two different types of growth. One is continuous. The dynamics of changes are in effect at all times. Okay, so it's like the Energizer Bunny. It just keeps growing and growing and growing. Okay, there is never a stopping point. Or we can have something called discrete growth, which is a sudden change in population after a certain period of time. Sorry guys, I'm getting over this cold. It's killing me. Okay, so how many of you have heard of the baby boomers? Which are
Oh,
the
baby
people that are
boomers,
getting
yeah.
ready to retire right now.
The what?
That's discrete growth. The baby boomers.
Baby
History,
bloomers.
right?
Baby
It's
droppers.
taught in history. Like we had one sudden like couple of years where like all these children were born.
Yeah, baby boomers
They're
are-
happening now where people are having
Oh,
enough
baby
children
boomers.
to.
So the population's decreasing.
Yeah,
Like boomerang.
Okay.
it's happening now.
No, like boomers like, oh my gosh, here's 100 babies.
Dang,
Yeah,
that's a
that-
boomer.
Okay. So that's what happened. That's discrete growth. Okay. It's an automatic sudden change. Okay. Continuous growth would be like we had 5 babies in 2017, 5 babies in 2018. Like it's a continuous thing. It constantly happens.
I got
Okay.
3 kids.
No, you don't.
Awesome. Congratulations. Transition. This is the regular interval.
Who's the victim, sir?
Okay. This is the regular interval of times between changes to the population. So how often is this happening? We talked about this when we talked about Leslie matrices. Is it happening every 6 months? Is it happening every 2 years? How often is it happening? Okay, so discrete growth example, we talked about the baby boomers.
Baby boomers, baby.
Any questions so far?
No.
We're going to start with arithmetic sequences and we're going to build ourselves up to geometric sequences. Okay, this also ties into money. And y'all like money, so
Of course,
I'm hoping that'll
course.
go.
I'll let you have it, but not.
Okay, think about it. You put so much money into your savings account, how much you're going to end up with at the end of 5 years. That's what this chapter does. Okay, so basic questions that you'll be able to answer in this chapter. What will happen to a given population over time? Okay, is it going to grow? Is it going to stop? What are the long-term patterns of growth if we have any? transition rule that we need to look at is when does it happen and how does it change? So we've got this population sequence. P sub 0 is your initial population. How many do you start with? Okay. Your next population is how much after a year or 6 months, depending on how often your transition's happening. So P sub n is the size of the population. N transitions. Okay, bless you.
Bless you.
How many transitions do you want to happen? Are we doing it for 8 transitions? Are we doing it for 12 transitions? So on and so forth. And P sub 0 is your initial value. And we're going to take a look at some examples. Good. All right, here's your first example. The number of cars produced is expected to increase by 25 every 2 months. If the company started with 100 cars, find the population sequence. So your transition, how often is this happening?
2 months.
Every 2 months. Your transition rule is something called a recursive sequence. Okay, it's an equation. So your new answer, P sub n, equals the previous number, which is written as P sub n minus 1, and it's changing by 25 each time. Okay. So let's create our sequence. How many cars do I start with?
100.
I start with 100. Okay. This is saying to find the next one, I have to take 100 and add 25 to it. So what's my next number?
125.
To find P sub 2, I have to take P sub 1 and add 25. So I have to take this number and add 25. 150. And you keep going.
175.
175.
Done.
Okay. So all this means is you have to go back and take what happened before and add another 25. Take what happened before and add another 25. Okay. It's called a recursive sequence. 1A. How many months have passed for P sub 9?
9.
18.
What?
Remember, each transition is 2 months. If I have 9 transitions, 9 times 2, 18 months have passed. What is the number of cars produced after 5 transitions? 225. We've got to do this another 2 times. So you get 200 and then 225. Okay. 1C. What is the number of cars produced after 1 year? 250? How'd you get that? I'm not saying it's not.
I did it in my head, that's how.
How though?
Because-
How many transitions happen in 1 year? 6. Okay, so you need 6 times. We've gone to 5, so 6 takes me to 250. You weren't wrong. I just wanted to hear your thought process on it. Questions?
No, madam.
Does it get harder? That's always the question. Of course it is.
That's what they have.
Next one. Let's get it.
Let's get it.
Let's get it.
Okay, Michael expects to double his profit every 6 months on his investments and has already earned 120 in profit. Transition,
6 months.
6 months.
Let's get it.
Transition rule. What are we doing to my number every 6 months? Doubling it. So how do I write that in mathematical terms? 2 times whatever, okay? So P sub n equals 2 times the previous number. So whatever I start with, I multiply by 2, and then I take that number and I multiply by 2.
Right.
So how much profit is Michael making in the 8th generation? The 8th transition. Generation is another term for transition.
Wait.
It's okay. Let's create it. So we start with 120. Then we go to what?
40.
240,
480.
480,
960.
960,
That's how much I got.
5,760.
It's 9,000. I mean,
No, that's the answer.
1,920.
5,750 the answer.
Oh, wait a minute.
This is
Wait.
1, 2, 3,
No, that's
4,
not 4. I'll just say the answer.
Oh.
5. So what comes fifth?
Wait, 4 is wrong.
Well, no, I was saying 4 is the answer.
That's a total.
Yeah.
Oh.
Why you erase 4? Ain't that was good?
Oh, they just told me that's not the answer.
No, that.
1920.
Wait a minute, how did you get there? Oh yeah, that's what I said, 1920.
Hold on, we're not even at the 8th generation yet. We're only at the 4th.
3,840.
3,840.
7,680.
Okay. 5, 6. I need 7, 8.
15,360.
360. And my 8th generation is?
30,700.
Okay. There's your answer. After 8 years, you can make $30,720 in profit.
I mean, I got that in my bank account right now, so I ain't even worried.
I'm sorry, 4 years, sorry. 8th generation, 6 months, 4 years. Okay, so this is 4 years worth of profit. How much profit has Michael made in the 3rd year of investing?
7,000.
7,680. Okay, again, this is every 6 months. So that's twice a year, which gives you the 6 number. How many years into the future does P sub 36 represent for Michael? How many generations?
18.
Well, it's 36 generations, which is 18 years. Perfect. 36 generations, which is 18 years.
When we got to read finish this.
What happened? Homework today?
They'll probably just be practice problems in your note packet. If I feel like giving homework.
Cool.
I don't know. We'll see. Because tomorrow's benchmark. So I might just give it to you guys tomorrow. You can work on it after your benchmark or whatever. Okay. Linear growth. What does the word linear mean?
Line.
Line. Guess what that also means? Arithmetic sequence.
No.
Okay. So, example problem number 1. A city is considering a new law to restrict the monthly amount of garbage allowed into the local landfill to a maximum of 12 tons a month. Although there is currently only 800 tons of garbage in the landfill, there is a concern that the landfill will reach its maximum capacity of 2,000 tons. What is my transition here? How often is this happening? Monthly, okay? It says monthly here, so my transition is monthly. Or 1 month. My transition rule. What's it gaining every month? 12 tons. So P sub n equals P sub n minus 1 plus 12. Write the population sequence. How much do I start with of garbage? 800. So after one transition, I'm at 812, 824, 836, 848, 860, okay, etc., etc. Plot and connect the points of the sequence. You just told me this is linear growth, so what should this look like? It should look like a line, a straight line, okay? So, at 0, we're at 800. We're just going to make this go up by 12. So 812, 824, 836, 848, 860. Okay, so any type of arithmetic sequence should always create a straight line. Okay, so you already know this formula. They're just going to change letters for you. So we've got line, y equals, how do I write a line? Something, something plus something. Mx plus b. Y equals mx plus b. What does m represent? Slope.
Dang, I forgot this. This is
Oh, we're going old school now.
Please no.
M is your slope, B is your what? Y-intercept. Okay, so y-intercept, starting point. Slope, how much it's going up by? So let's create the equation for this then. Y equals, how much trash? It's going up by 12. So my slope here is 12. X plus, how much trash did I start with? 800.
Oh, that's how you do
That's it. Now you can use this equation to solve for anything that you want. Okay, so how much garbage will be in the landfill 5 years from now? Okay, in terms of this equation. First off, we're looking at 5 years. How many transitions have happened in 5 years? 60. Okay, remember, it's 5 times 12 months a year, so that's 60 transitions. Plug it in. Y equals 12 times your 60 transitions plus 800. So Y equals, how much trash is in my landfill after 5 years? 15,000, you said? 15,200. Okay, 15,200 tons. How long will it take before the landfill reaches 20,000 ton capacity? So now they tell us how many tons we have. Where do I plug that in? I plug it in for Y. Okay, 20,000. That's our maximum. We want to find out how many transitions it takes to get there. So we're solving for X this time.
Yeah, I know what you do. You subtract 800.
Subtract 800. So 19,200 equals 12x.
And then, wait a minute.
Divide by 12. So what does x equal? 1,600. How do I find out how many years that is? Because this is in months right now, don't forget. Divide this by 12.
233.30.
133.30 years. And it can happen for a good long time.
1 year.
Okay.
You know I got that much money in my bank account right now.
Oh yeah?
Yeah. Why you using Lexus? Because I don't want to spend it. This is a cover up.
Oh.
Cover, no one tells all that you got that much money.
But y'all don't know my bank account number.
Because he's trying to brag.
I know where you live.
If you did,
Not to mention-
Nothing.
he's full of crap.
Okay. So, a linear growth model, we've already talked about this, produces what we call an arithmetic sequence. Okay, so the difference between your terms is a constant. You're either adding the same number over and over again because it's growing, or you're subtracting the same number over and over again because it's decreasing. Okay, the number that you do this by is called your common difference. So if you're adding by 2, your common difference is 2. If you're adding by 12, your common difference is 12. Your initial population is P sub 0. They also like to call this your seed. Okay, think about it. You can't grow a plant without a seed. You've got to have a starting point, and your seed is your starting point. So here, they want us to determine the common difference for each of the following arithmetic sequences. What is my pattern happening here? Plus 4. So my common difference is plus 4. What is happening here?
Minus
Minus 7. And finally, the last one,
Minus 26.
minus 26. Perfect. Okay, let's say you could not see the pattern. Okay, if you can't literally see the pattern, how we find it is pick one number, any random number you want, and subtract the number that comes before it. And that will give you your pattern every time. So pick any random number you want and subtract the number that comes before it.
Even when it's like multiplying.
No, that's going to be different. When we get to geometric, I'll show you how to do that too. Okay, explicit formula. If you start with your initial value, P sub n equals P sub 0 plus your difference times n. This is basically your y equals mx is over here plus b.
Okay. Thank you.
So your explicit formula can be based off of y equals mx plus b.
Or B plus MX.
Or b plus mx.
Or
Is that B and?
X plus B equals Y.
Either way. If I add 2 and 5 or 5 and 2, I still get 7.
Mm-hmm.
Does not matter what order you do it in. Okay, they have another formula. If we only know the first term in the sequence and not the initial term, you can use a sub n equals a sub 1 plus n minus 1 times d. More than likely, you will always use the first formula rather than the second formula, but I do have to give it to you. It feels like today is dragging. Okay, so all we're going to work on for these examples is how to come up with the recursive formula and the explicit formula. I'm not even so much concerned. Skip it. You don't even tell me I did that. You gotta be kidding. I put them in out of order.
I didn't see those.
That's what he just said. I think I might have skipped copying that page. No.
Ricky, you do a copy.
Brand new. We can just take a picture of it.
No, we can't have all of them.
You really, really need that page too. All right. We're gonna take a mini pause break.
Yeah.
Actually, let's go over this page, just this. And then we'll stop and I'll make copies while you're at lunch. And then we'll come back to this. Okay. All right. We can at least get through this page. So I'm not really worried about the recursive sequence and formula. I'm more worried about the explicit, but we're gonna do both. So first thing you need to do is find the common difference. Plus 6. Okay, so that means recursively, it's P sub n equals P sub n minus 1 plus 6. That's the easiest one we can do. Okay, explicit formula. Y equals mx plus b. So y equals, what is my slope? 6. It's going up by 6. Where do I start? 7. There it is. Okay. It gets harder when they don't give you the initial number. Part B. Plus 2. So P sub n equals P sub n minus 1 plus 2, which means this equals y equals 2x. Just do minus 3. Don't confuse yourself. If it's a negative number you're plugging in there, just do minus 3. C. Minus 5. So P sub n equals P sub n minus 1 minus 5. Y equals negative 5x plus 2. Okay. D and E, let's just do explicit formula. Y equals. What's my pattern here? Minus 3, x, minus 3. Perfect. And finally, E, 19. So Y equals 19x plus 42. Perfect. Questions, issues, problems? Okay.
Quick time.
Yeah, maybe we